Hi, welcome back to Mr. Slover's Math. Today we're doing solving systems of equations by substitution again, but this time we're going to get special answers, meaning it won't just be one solution. So our warm-up is just practicing using substitution to solve the following systems of linear equations. So this is what we talked about yesterday. There were 5 steps, and if need be, it's not on the warm-up, but you can just kind of look right down here for those 5 steps to remind you on what you need to do. So we've got our variable isolated. We have it all by itself. So anywhere we see a y, we're going to plug in an x plus 3. So everything else in the bottom equation stays the same. The 4x, the plus, the equals, the 18. The only thing changing is the y. So I'm replacing the y, or I'm substituting the y for the x plus 3. And then I collect like terms. So I get 5x plus 3 equals 18. And then I just keep solving. Subtract 3, divide by 5. X is 3. So now I'm on to step 4. Plug the answer from step 3 into your equation. So if x is 3, the top equation looks way easier to solve for. So I'm going to do y equals 3 plus 3, y equals 6. So I write my answer as an ordered pair. So the notes for today are the same thing. They're just the special case ones. So they're not going to be, they could be one solution, but they may be something different. So what happens if, after we start following these steps, what happens if we don't get x equals a number? So step 1, we're solving one equation for x or y. So y is all by itself. We substitute in negative 2x minus 4. Don't forget that negative. Substitute that in when we see a y. We get 6x plus 3 times this quantity, and then equals negative 12. We're going to distribute that 3. We end up with 6x minus 12 equals 12. Equals negative 12. So when I collect like terms, I get negative 12 equals negative 12. Well, wait a minute, Mr. Silver. What happened to the x's? 6x minus 6x. I have $6. I spend $6. They're gone. All that's left is this, the negative 12. And your variables can reduce to 0. That is okay. They can eliminate. They can be gone. There's nothing wrong with that. So I get negative 12 equals negative 12, and I think to myself, is that a true statement? Yeah, that is a true statement. Negative 12 does equal negative 12. That's a true statement. So because this is a true statement, my solution is many solutions. Remember, graphically, that means that these two lines are the exact same line. Okay, that's what that many solutions is. Any x or y value that you pick will make both equations true. So the next one, same thing, we're solving systems of equations. I have y isolated. I have y solved all by itself. So I'm going to plug in 2x minus 3 where I see a y. Now this one's a little bit tricky. It says 2x minus y equals 8. So that 2x and that minus and the equals and the 8 are all still there. It is very, very, very common for students to forget that negative right there. You have to include it. Okay, because it's saying I'm subtracting y, so I'm subtracting everything that's in parentheses. That's why I'm distributing a negative 1. Right? This negative parentheses is really saying negative 1 times all the stuff that's inside those parentheses. So when I distribute, I get 2x minus 2x plus 3 equals 8. 2x minus 2x are like terms. They're on the same side of the equal sign. 2 minus 2 is 0. My variables are gone again. I'm left with 3 equals 8. Well, I know 3 does not equal 8, so that's not a true statement. So because it's not a true statement, I'm writing no solution. And remember, graphically, that means that these two lines do not intersect. It means that they are actually parallel. Letter B, you can try on your own. And then letter C, I have y isolated. I have y solved for. I plugged it in. I distribute a negative 4. So I get 8x minus 4x minus 4 equals negative 4. So 8x minus 4x gives me 4x. I know there's a lot of 4's going on. So 4x minus 4 equals negative 4. I add 4. I get 4x equals 0. And lots of students like to stop right here and say, wait a minute, Mr. Slover, 4x equals 0? That's not possible. It is possible, right? 4x, 4 times x equals 0. 4 times something is going to give us 0. So to undo that multiplication, I divide. 0 divided by 4 is 0. It's okay to get x equals 0. It's okay to even get y equals 0. It's okay to get 0, 0 as a solution. That is okay. But please make sure if you get 4x equals 0 or something similar that you don't just stop and say no solution. Okay? 4x equals 0 is okay to get. That means that that value, x, does equal 0. So I plug 0 in because I got to solve for the y value. So 0 plus 1, I get y is 1, and I have a solution. I have one solution. I have an ordered pair at 0, 1. So I would write that as my solution. So today we were still doing systems of equations by substitution, but we were focusing on our special equations. So ones where we get no solution because our statements are not true. One where we get many solutions where our statement is true. And one where you have x equals 0. That is totally possible. So if you have any